An important consideration in evaluating fire hydrants in general is to understand the different types of fire hydrants that we might find in a water distribution system. To begin with, we'll start with the dry barrel fire hydrant. The important concept of a dry barrel fire hydrant is that the barrel itself is dry when the hydrant is closed, meaning that it's empty. What basically happens once the hydrant has been used and the barrel charged is when the hydrant is closed, the water drains out. There's a drain mechanism in the base of the hydrant that allows water to drain so that the barrel of the hydrant is empty when not in use. That's important so that when you have freezing climates, that water in the barrel of the fire hydrant doesn't freeze and turn your fire hydrant into a block of ice. Essentially what happens, the hydrant's equipped with a main valve is what it's called in the body of the hydrant, typically down at the bottom. You can kind of see in the picture down here that there's a valve down at the bottom of the assembly so that when the valve is closed, no water gets into the hydrant itself, and the drain in the barrel allows water to drain out after it's been used. So once again, that's going to avoid water freezing in the barrel in colder climates. You can see in this exhibit here, the ground line may be here, the portion of the above ground portion of the hydrant, and then the valve is actually located below ground so that you keep water out of the barrel of the hydrant, certainly within that kind of frost zone that we've talked about in the past. The characteristic way to determine and identify a dry barrel fire hydrant is the presence of an operating nut up at the top of the hydrant. Other types of hydrants do not have that nut. That operating nut is the way that the valve in the bottom of the hydrant assembly is raised or lowered or opened or closed depending on which type of valve it might be. In addition to keeping the hydrant from freezing, these types of hydrants can help avoid lost water if the hydrant's hit by a car, to the extent that the valve at the base is not damaged. There's other ways of doing that we'll talk about later, including breakaway spools and bolts and whatnot. There are a couple variations of dry barrel fire hydrants that we want to be familiar with. The wet top fire hydrant is one in which the operating stem threads are exposed to the water. So you can kind of see in the exhibit that the stem itself, some of those threads are exposed to the water. That's a wet top fire hydrant. In a dry top fire hydrant, let's back up one, it's the opposite. You can see that the threads on the stem here are in a chamber within the body of the hydrant that is isolated from the water. Looking at a couple other exhibits, similarly, you can see in this illustration that the threads are protected from the water, as well as you can see in this hydrant cutaway. You can see the threads right there, and the body of the hydrant comes down here. So the wet areas are outside of that chamber, meaning that it's a dry top fire hydrant where the dry top protects those operating stem threads. So that's the dry barrel fire hydrant. Once again, the primary issue with a dry barrel hydrant is that we keep it dry when the hydrant is closed, and the primary benefit of that is to avoid water freezing in the barrel in colder climates. So moving to a wet barrel fire hydrant, in which the opposite is true, the barrel is full of water at all times. So this is not really well suited to freezing climates, because that water in the barrel would freeze and you'd have, like I said before, a block of ice that's not going to be effective when you need the hydrant to fight fires. And once again, if the barrel's full of water, if it is damaged, if it is hit by a car, you have the potential to lose some more water. We can talk a little more about that later, but the main issue is the wet barrel fire hydrant does not have that main valve that we talked about before. The main valve, again, is the valve that isolates the barrel of the dry barrel fire hydrant. In a wet barrel fire hydrant, we don't have a main valve. Each nozzle has a separate valve. As you can see in the exhibit here, there's a nozzle here that's actuated by an operating nut on this side. Similarly with the nozzle up here. This is a third nozzle over here. So each individual nozzle, each individual outlet is a separate valve. There is no main valve that controls water through the entire fire hydrant. So, every agency is a little bit different. Again, in warmer climates, There's less operating below ground operating assemblies in in a wet barrel hydrant. Most of the hydrants that El Toro Water District puts in now are all wet barrel. We did have a lot of dry barrel fire hydrants. We've been replacing them over time to mostly wet barrel, which seemed to be a little more appropriate for the climate in which we serve. Once again, just like the dry barrel hydrant is easily identified by the presence of an operating nut on top, a wet barrel hydrant is similarly identifiable by the lack of that operating nut on top of the fire hydrant. Once again, as we look at the kind of comparison, the wet barrel hydrant not really suitable to colder climates. The dry barrel keeps water out of the barrel so that you can protect it in the event of freezing climates, whereas a wet barrel would not do that. So in the appropriate climate and appropriate environment, it would work just fine. The term warm climate fire hydrant is basically a variation of the dry barrel hydrant, but the main valve, as opposed to being down at the bottom of the assembly below ground, is at ground elevation. So the lower portion of the barrel is full of water. You don't have a drain mechanism, so it's kind of a hybrid between the wet barrel and the dry barrel. The term flush fire hydrant, and we're going to talk about a flush fire hydrant and a flushing hydrant, so let's make sure we draw the distinction between them. A flush fire hydrant is simply one that's below ground. So the entire hydrant assembly, even the nozzles, are in some sort of vault below ground. That's going to be for typically some sort of aesthetic reasons. Perhaps there's a physical obstruction, or you're trying to avoid any kind of physical obstruction. Maybe perhaps an airport runway or something like that, where you're trying to avoid above ground facilities. A flushing hydrant, again, as opposed to the flush hydrant, this is now a flushing hydrant, is simply used for flushing operations. It's not designed for fire flow. They're typically going to be smaller diameter for flushing applications, maybe a 4-inch or something like that. This particular example is located at our large 275 million gallon reservoir that has a floating cover that we clean periodically. So we have flushing hydrants located around the reservoir that we use as a source of water when we're cleaning the cover. So once again, these are not for fire flow conditions. I'm avoiding using the term flushing fire hydrant because it's not. It's a flushing hydrant. It's a source of water for flushing operations only. So that's a variation of the theme when it comes to hydrants themselves. So those are a quick summary of some of the different types of hydrants. Again, the primary types that you're going to see in a water distribution system are going to be those wet barrel and dry barrel fire hydrants. Both provide essentially the same function in terms of providing water for fire, as well as a variety of other uses that we'll talk about a little bit later, and make up the majority of hydrants that you would see in a system. The other ones are really, in all reality, few and far between.